Hey there, class. Mr. Plosky here. Hope you're having a good day so far. We are continuing with a new chapter. We're skipping chapter 4, and we're moving on to chapter 5. We just decided chapter 4 was not as useful as chapter 5. We have a lot to get to, so chapter 5 is all about quadratic functions. That includes parabolas, that includes quadratic formula, factoring, that kind of stuff. So yeah, like a parabola is basically the arc that if you throw a ball through the air, it would be the arc that it follows before it hits the ground based on gravity. Parabolas are very useful for a lot of different applications and stuff, and so we'll be talking about that a little bit later. But this is 5.1, day 1. The name of the lesson is quadratic functions. So let's go ahead and get into this here. So there's a different couple of variations of quadratic functions, the form that you would write the equation. We have standard form, we have vertex form, and we have factored, or what do they call it in the other thing? Factored or intercept form. Okay, so we have 3 different versions of, kind of like with slope-intercept form, we had y equals mx plus b, we had y minus y1 equals m times x minus x1. That's point slope form. We also had ax plus by equals c. Those are different variations of linear equations. Okay, they're all different ways to write linear equations. We also have the same kind of thing with quadratics, which we'll talk about a little bit later. But today we're going to be starting with what's called standard form. So standard form is y equals ax squared plus bx plus z, and a does not equal 0. I'm going to box that. That's what we're going to be talking about today. We'll put that right in the middle there. All right, cool. So the graph of a this type of equation or function is U-shaped, and it's called a parabola. Say parabola out loud. Say parabola. You're probably not saying it, but that's how you say it. If it helps you to say it out loud, it's important. So it's called a parabola, and it has a vertex. Someone's turning in a lot of work right now. Sorry about that. With a vertex and AOS. And AOS is an important idea. It stands for axis of symmetry. Okay, a lot of this was covered in Algebra 1 in Chapter 10, I believe. Which is 2 years ago for most of you guys. So it's been a long time since we talked about this, but we're circling back because it is important for Algebra 2. So we've been talking about parent graphs, like remember y equals absolute value of x. That was the parent graph for absolute value equations. We also have a parent graph for quadratic functions, and it is this. It is y equals x squared is how you'll normally see it. But it's also, if you look at the standard form, we also have bx plus c. Well, what's bx and c in this problem? Well, when it's just y equals x squared, we could also write this as y equals x squared plus 0x plus 0. That's our a, b, and c. So our a is what's in front of x. That's going to be a 1. Our b is going to equal 0, and our c is going to equal 0 as well. It is very important to be able to identify a, b, and c with these kind of problems, with quadratic formula, with graphing and stuff. So just be aware that a is what's in front of x squared, b is what's in front of x, and c is what's by itself, the constant. And if there's a missing term in any of these things here, it's going to be 0 in front of that. So if there's no x term, it's going to be 0x. If there's no c term, it's going to be 0. So just keep that in mind, okay? There is always an a, b, and c term no matter how it's written for standard form. All right, let's go back to red now. So the vertex of the parent graph is going to start at 0, 0. All right. And we actually have a formula to find the coordinates of the vertex using algebra. So the x coordinates of the vertex has a formula. This is very important, so make sure you make a note of this. It's opposite of b over 2a. Not always negative b, it's opposite of b over 2a. All right, opposite of b over 2a. That's why we need to find a, b, and c for every problem, because we need to be able to find the vertex algebraically without graphing. Because we're going to graph, but we need the vertex using algebra, using a, b, and c. The axis of symmetry, the AOS, the equation for axis of symmetry is x equals the x-coordinate of the vertex, which is opposite of b over 2a. Every single time for standard form, it is opposite of b over 2a. So for this one, if we plug in, let's go ahead and do that. So we're going to do opposite of b over 2a, so it's going to be x equals, well, b is 0, so opposite of 0 is just negative 0, I guess. It's always negative, but if you had b was negative 3, you would have opposite of negative 3 over whatever's left over, okay? But we have 0, so we just put the negative in front just because we want to stick to the formula. 2 times, what's the a value for this problem? Well, the a value is 1, so we get negative 0 over 2 times 1. Well, negative 0, there's no such thing as negative 0, so it's just going to be 0, right? And 2 times 1 is 2, so it's going to be 0 for this problem. So the axis of symmetry for the parent graph is x equals 0. And that's all you have to do for axis of symmetry. Axis of symmetry is not on the graph when you graph a parabola. It's not like, I'm going to use a dashed line when we graph these. It's just a useful tool to be able to find the symmetry of a graph, and it's used for other applications as well. So don't use a solid line. Whenever you graph a parabola, you're not going to graph, a solid line down the middle where each parabola has a line right down the middle of it. It's going to be a dashed line. It's kind of like it's an imaginary kind of useful line that we use, okay? Okay, so we now know, so we know the vertex is 0, 0. And so after we find the x-coordinate of the vertex, which is 0, to find the y-coordinate, we're going to take that, we're going to take the x-coordinate we found, we're going to plug into the original equation. So we have y equals x squared. So we're going to do y equals parentheses. Wherever you see an x, you're going to plug in whatever we're plugging in, which is 0. And 0 squared is 0. So our vertex is 0, 0. So to find the x-coordinate of the vertex, plug in negative b over 2a. To find the y-coordinate, you're going to substitute whatever you get for x, which is 0, into the original equation, which is y equals x squared, or whatever the original equation was. Okay, so our vertex is going to be 0, 0. I'm going to put a little v right here in quotes. That's our vertex. Okay, now we have, after you figure out what your vertex is, you want to pick numbers to the right and to the left of 0. So what numbers are to the right and left of 0? Well, if you go with 0 right here, 1 and 2 are to the right, and negative 1 and negative 2 are to the left. That's where these numbers came from over here. Okay, so what we need to do is we need to plug in 1 and 2 and negative 1 and negative 2. And actually there's a shortcut. Because parabolas are symmetrical, we only need to plug in half of the table, and then we can just mirror the other half. All right, so what does that mean? Well, let's plug in 1. So we're going to do y equals x squared. We're going to plug in, let's write x squared actually. And we're going to do x squared. We're going to plug in 1 in for x. So what is 1 squared going to be? Well, that's going to be 1, right? So 1 is going to be 1. It's going to be one of our points here. Let's plug it. Don't write this down, but let's plug in negative 1, right? Y equals x squared. We're going to plug in negative 1 in parentheses squared. Okay, wherever you see an x, you have to put parentheses around the x and plug in the number right there for x between exponents and everything. Okay, so what is negative 1 squared going to be? Well, it's going to be positive 1. So you can see we got the same thing on both sides here, but all we need to do is figure out one side by plugging it into the original value. And we're going to draw these lines like this, or these little arrows here. They're going to mirror. If you find the vertex and you find one half of the parabola, the other half will also mirror. So we're going to draw these little arrows to know that they're going to mirror like this. Okay, let's do 2 now. So we have y equals x squared. We're going to plug in 2 for x. We got 2 parentheses squared. 2 times 2 is going to be 4. So if we get 2 for 4, we plug in negative 2 squared. Well, negative 2 times negative 2 is also 4. So you can see this is what I mean by mirroring. Okay? So once you find the vertex, find numbers exactly to the right and to the left of the number by 1. So 1, 2, negative 1, negative 2, and then find 1 half. I would plug in the easier side and then just mirror the other side. So 1 matches with negative 1, 2 matches with negative 2, and then we get all our points here. So these are the points we have. We have negative 2, 4, negative 1, 1, 0, 0, 1, 2, and 2, 4. If we connect these points, it's going to make a parabola for us. Okay, so let's go ahead and graph this. We have 0, 0. So we have 0, 0 is going to be right in the middle. We have 1, 1, so we're going to go right 1, up 1. We have negative 1, 1. I'm going to mirror it, go negative 1, up 1. I like to go so that's kind of symmetrical here. Then we have 2, 4, so right 2, up 4, 1, 2, 3, 4. We also can go the exact opposite direction as left 2, up 4. And you can see we have this nice, it's going to be a U shape. We're going to connect it like this. It's not going to be perfect on my graph, but it's going to make a nice upwards looking U. That's the parent graph for, it's a graph that all other quadratic equations are taken from. This is the starting point, okay? And that is the parent graph, but also we need to draw the axis of symmetry. We're not going to use a solid line, we're going to use a dashed line. We said x equals 0 is the parent graph. Well, remember, Hoy Bucks, x equals 0 is a vertical line. So through parabolas, it's always going to be a vertical line. Let's use a more heavy line here. It's going to be a vertical line through x equals 0. That was our axis of symmetry. We said it was x equals 0, right? So this is our axis of symmetry, AOS, and it is x equals 0, and there's the line. It's a vertical line through x equals 0. All right, sounds good. How many more we got here? We got 1, 2, 3, 2, 3. We got 3 more examples to do and got more things to talk about. Okay, so we have y equals 2x squared. We're doing transformations of the parent function y equals x squared. We're going to do variations of this parent function. So y equals 2x squared. Well, what's our a, b, and c? Well, like I said, it's just y equals 2x squared. That's our a. 2 is going to be a, so we have 2x squared. But we also are missing the b and the c, which means we have a 0x plus 0. So our a is 2, our b is 0, and our c is 0. Okay? So, yeah, let's keep moving along here. So, the x-coordinate of the vertex, let me zoom in a little bit. X-coordinate of the vertex equals negative b over 2a. So that's going to equal, well, b was 0, so we have negative 0, or opposite of 0, over 2 times a, which is 2, which equals 0 over 4. Oops, I'm going way too big. Sorry, I'm going to write this a little bit smaller. Give me a second here. So we're going to do x coordinate of the vertex, which equals negative b over 2a. So we're going to plug in negative b. Opposite of b is negative 0 over 2 times a, which was 2, which equals 0 over 4, which equals 0. So the x-coordinate of our vertex is 0. That's where we got the 0 from. The numbers are to the left and right of 0 are 1 and 2. To the left of 0 are negative 1 and negative 2. Okay, so we got 0 as our x-coordinate of our vertex. How do we find the y-coordinate of the vertex? Well, we need to plug in 0 into the original equation. So over here, we're going to do y equals 2. And now I'm going to plug, wherever I see, exactly where I see an x, I'm going to plug in 0. So I'm going to put parentheses there. So it's going to be y equals, you can see right where the parentheses are, the 0 replaces the x perfectly. Okay, be careful, you have to use parentheses when you plug stuff into here. So we got y equals 2 times, what's 0 squared going to be? We got to do exponents first. 2 times 0, which equals 0. So our y-coordinate of our vertex is 0. Okay, let's do 1 and 2 now. Let's do 1 and 2. So you could do negative 1 and negative 2, but I think 1 and 2 are easier to plug in. So we're going to do 2 times 1 squared. Well, 1 squared is 1, so we have 2 times 1, which equals 2. So the y-coordinate of the point of 1 is 2, and that means also negative 1 is also going to be 2. So this is, wait, let me fix that, sorry. So we have 2, this is the vertex. So we got 2 and 2 over here. And then we also have y equals 2. We're plugging in 2 now. We're plugging in 2 in for the x, 2 squared. So we got 2 times 2 squared is 4, which equals 8. So we have 8 and also 8 over here, because it's going to mirror or reflect nicely. Okay, so let's graph this here and see what it looks like. So we have 0, 0 right in the middle. We have 1, 2, so right 1 up 2. We have left 1 up 2, got to mirror it nicely. And then we have 2, 8. So right 2 up 8. 1, 2, 3, 4. The graph goes up to 5. So we're going to go 6, 7, 8 up here. And over here, same thing, left 2, up 8, so 6, 7, 8. That wasn't very good. 6, that's not good. Sorry, it's kind of hard to graph this. 7, 8. Okay, so there's our graph. And it's kind of hard to read, but it'll do. Okay, so what's the difference between this graph and the last graph? Well, it's much steeper, right? So this is going to be a skinnier version, and it's also going to be a vertical stretch. Okay, so if you multiply, kind of like with what we did with absolute value equations, when we put a bigger number in the front of the absolute value, so y equals 2 times absolute value of x, it stretched it vertically, made it skinnier. Same thing here. If you have a 2 or bigger, or anything bigger than 1, it's going to stretch vertically and become more skinny up and down. And if you have something that's less than 1, like a fraction, that's going to be like more a wider kind of parabola. So if you had like y equals 1/2 x squared, that's going to be wider. Okay, but if the a value is greater than 1, it's going to be skinnier. All right, cool. We're cruising along here. Let's use a different color. All right, now we have y equals. Draw a line here to get some space. Or not. All right, we have y equals negative x squared. So let's rewrite this with the a, b, and c value involved. So negative x squared, we have negative 1x squared. That's our a. Do we have an x and a y, x and a b and c value? We don't. So we're going to put plus 0x plus 0. If you don't have to do that if you're comfortable just figuring it out in your head, but usually it helps people figure out. Sometimes people will label like c or b the wrong number, so I want to make sure we do that correctly. So this is our a. This is our B, this is our C. Okay, so the x-coordinate of the vertex is negative b over 2a. So we're going to do opposite of b, which is 0. So opposite is 0 over 2 times a, which is negative 1. And that equals 0 over negative 2, which equals 0. So the x-coordinate of a vertex is 0. That's where the 0 came from. Then we go to the left and right of 0. So we got 1 and 2 is to the right of the number line of 0. And negative 1, negative 2 is to the left of the number line from 0. Now we have to find the y value. So we're going to plug in. So we have y equals, where should we write that? Not down there. Let's go over here. Let's do y equals, so we're going to plug into negative x squared, we're going to plug in 0. So we have negative parentheses 0 squared, okay? Wherever we see an x, right there, you see where I'm circling? It has to go right between the negative and the squared, or else it's going to goof you up. Don't forget the parentheses. We have negative 0 squared is 0, so negative 0 is just equals 0. So the y-coordinate of the vertex, after plugging in the x-coordinate into the original equation to solve for y, we get 0, 0 is our solution there for that one. So this is our vertex. Okay, now we need to find 1 and 2. So we're going to plug in 1 and 2. So y equals negative 1 squared. That's the original number, which was negative x squared. So x is 1. We plug in that. So 1 squared is going to be positive 1. So we get negative 1. So our answer for this one is negative 1. Also, the other one's going to be negative 1. Remember, it's going to mirror. Okay. I forgot to mention with the last one too, the axis of symmetry equals x equals 0. Same thing down here, it's going to be x equals 0. Okay, this x equals the x-coordinate of the vertex. All right, let's do 2 now. We got 2. So we're going to do plug in 2. So we have y equals negative parentheses 2 all squared. So 2 squared is 4, so we get negative 4. So we have negative 4 and negative 4. That was bad 4. All right, so let's graph this now. I think we got everything. Let's see what it looks. We'll make some notes about what it looks like after that, okay? So we got 0, 0s right in the middle again. We have 1, -1, so right 1, down 1. We have -1, -1, left 1, down 1. Ooh, looks like it's going down. That's interesting. Then we got 2, -4, so right 2, down 4. And we got -2, -4, left 2, down 4. So this one is actually open down. All right, is open down. So, yeah, so this one actually, what happened between this graph and the apparent graph is it's reflected over the x-axis, and it also, A is negative. Okay, so if A is negative, if the A value is negative, it's going to open down no matter what. If A is negative, it's going to open down. Same thing with absolute value functions too, okay? So if A is negative, it's going to open down, and then a number in front of the x squared is going to change like how narrow or skinny, how skinny or wide it is, and also if it's stretched vertically or not. Okay? So that's the essence of this. So those are the different kind of transformations that you'll see. All right, we got another page to do here. Let's keep cruising along. So characteristics of standard form. So we had y, standard form is y equals ax squared. Memorize this formula too, by the way. It's very important. Plus bx plus c. If a is greater than 0 or is positive, it's going to open up. So it's going to be like this. That's pretty sloppy, actually. And if a is negative, it's going to open down. All right. So we have the vertex is going to be x coordinate. You're going to plug in x coordinate. Wait, that's not what I wanted. Sorry, x coordinate equals negative b over 2a. That's the coordinate for the x coordinate of the vertex. The y coordinate, which is what I was going to write, that equals, you're going to plug in the x coordinate into the original equation. Plug in the x coordinate into the original equation to solve for y. The axis of symmetry. There are some situations where people goof up the axis of symmetry. So it's always x equals opposite of b over 2a. That's the formula. And these are very important. It's always an equation. Some people just write, like, for example, if they put, like, over here, they would put, like, instead of x equals 0 and x equals 0, they would put just 0. It's not just 0. It's not just a number. That's not an equation. That's not an axis of symmetry. That's just a number, okay? It's not just a number. It is always an equation, okay? It's going to be x equals whatever the number is. And it's always, it's a line. It is a line. Okay? All right. So now we have 2 more examples, and we're going to save some time here. I'm going to show you a shortcut to help you fill in the tables in a second here. But let's go ahead and get into this. Let's do it. All right. So we have, this is graph the quadratic function, label the vertex and axis of symmetry. All right. So we have y equals x squared plus 6x plus 10. So we got to find our a, b, and c. Well, there's a 1 in front of the x squared. So a is 1, b is 6, c is 10. So let's find the vertex. We got to make our own table here now. So we got to find the x coordinate of the vertex. So x equals opposite of b over 2a, which equals, well, b is 6, so negative 6 over 2 times a, which is 1, which equals negative 6 over 2, which equals negative 3. So our axis of symmetry is x equals negative 3. All right. So we have our x coordinate of our vertex, right? So now I got to find the y coordinate of the vertex. So we're going to plug in negative 3 into the original equation. So we have plugging in wherever we see an x, we're going to plug in negative 3. So we're going to do y equals negative 3 squared plus 6 times negative 3 plus 10. Okay, it's kind of tricky because we have a lot of stuff to plug in here. So we got negative 3 squared is 9 minus 6 times 3 is 18 plus 10. And then we have 9 minus 18 is negative 9. Negative 9 plus 10 equals 1. So our vertex is negative 3, 1. So let's go ahead and make a table now. That was too far. Sounds pretty solid, actually. Okay, so we have our table. Here's our x, here's our y. The middle value is going to be our vertex. So we said x was -3, and our y was 1. Okay, so this is our vertex. So we need to find numbers to the left and to the right of -3. So going to the right of -3 on the number line, what numbers are next? Well, it's -2 and -1. Numbers to the left of -3 are going to be -4 and -5. So here's a shortcut. This is how you plug stuff in over here, and I showed you that. But we're going to use Desmos Scientific Calculator now, and you can get this on your phones, you can use it on your laptop, you can use it on any device really, and I'm going to show you how to do that here, okay? So we're going to check -2 and -1, and I'm going to do it on a Desmos Scientific Calculator. So let's go ahead and do that. So we are plugging -2 into the original equation. So our original equation was it was x squared plus 6x plus 10. So I'm going to plug in -2. So we're going to do -2 squared. Where's squared at? You can do squared, or else what you can do is you can do the power of, oops, that's not what I wanted. Sorry. You can do to the power button like that, and that's going to make it to the power of 2. Then hit to the right. So -2 squared plus 6, parentheses, we're plugging in -2. And then we have plus 10. And then we do get 2, and that is the right answer on the right over here. Another trick for you is you can, if it's like a weird decimal, so we can hit enter, that's going to be our answer. But if you do like 11 divided by 3, something like that, there's a little button over here with a circle with like a fraction button. You can click like that, and it'll actually convert it from a decimal to a fraction for you, which is really nice. But if we go back to our problem, so for -2, our answer was 2. I would encourage you, don't do this for every single problem. That's going to take way too long. Use Desmos Scientific Calculator or another calculator, but I think the Scientific Calculator for Desmos is one of the best you can get. You can get it on your phone or anything. It's really good. Let's try our -1 now. So we're going to do, let's clear that. So we're going to do parentheses -1, parentheses power of 2, hit the next arrow, plus 6, parentheses -1, plus 10. And we get 5, and 5 is the right answer. So we get 2 and 5, and then these are also going to be reflected. So we're going to go like this. This is also going to be 2. This is also going to be 5. See how that saved us some time there instead of actually plugging it in all the time? That's a lot nicer. All right, let's graph this thing now. So we have -3, 1. So we're going to go left 3, up 1. Put a point. -2, 2. We're going to go left 2, up 2. And -4, 2. Left 4, up 2. Then we have -1, 5. Left 1, up 1, 2, 3, 4, 5. And then we also have -5, 5. So left 1, 2, 3, 4, 5, up 5. And there is our graph. Not perfect, but it'll do. This should be a perfect kind of U-shaped graph. And then what's our axis of symmetry? Well, it's x equals -3. So it's going to be a vertical line through x equals 3. X equals 3, -3 is a vertical line. We're going to use a dashed line. It's not an actual line that's going to be there on the graph. It's just there for our reference, okay? So there is our line. This is our AOS. Okay? All right. Why don't you go ahead and see if you can do number 2 on your own, and then we'll go through it in a second. All right, welcome back. Let's do it. Let's use this pink here. All right, we have y equals -3x squared plus 4. So we need to write our new equation so that it's we can see our a, b, and c nicely, which is y equals -3x squared is good. We do not have a b or a c value. We do not have a b value, so we're going to have 0x, and then c is a number all by itself. So this is our a, b, and c. So we're going to find the, first thing we have to do is find the vertex. We're going to do x equals opposite of b over 2a. Opposite of b is 0. Opposite of 0 over 2 times a, which is -3. And that's going to equal, let's see here, 0. This is going to be 0 over -6, which equals 0. The y-coordinate of the vertex, we're going to plug 0 into the original equation. So we're going to do -3 times 0 squared plus 4, and that's going to equal, you can plug that into Desmos if you want, and that's going to equal 4. Also, we found this should be the axis of symmetry is going to equal x equals 0, because that's our x-coordinate of our vertex. Okay, so our table, we're going to do a table here. Do a table, whoops. That was bad, let's fix that. 1, 2, 3, 4. Getting good at that. Here's our x and y table. So our vertex with 0, 4 in the middle. This is our vertex. Then the numbers to the right of 0 are 1 and 2. To the left of 0 are -1 and -2. Okay. If you plug 1 into the original equation, like I did right here for y, into Desmos, you're going to plug in 1 in for x right here. You are going to get for your values 1 and -8. And same thing over here, 1 and -8. So these are going to work. And these are going to work. Okay, they're going to mirror. Let's graph this now. So we have, let's see, 0, 4. So we're going to go 0 up 4. We're going to go left 1, down 1. It's -1, 1, and right 1, down 1. Oh, wait, sorry, up. We're going to go left 1, up 1, and right 1, up 1. And then we're also going to go down 8, left 2, down 8, which is going to be way down here. It's not going to be perfect, and then right 2, down 8 is going to be down here somewhere. So it's a very steep U shape down here. And there's our graph, and let's use our nice green here. Our axis of symmetry is x equals 0, so we're going to do a vertical line through x equals 0. And this is not on the graph, but it's just to help us. Axis of symmetry is going to be important for later, okay? All right, last thing for today. This is a very long lesson. I apologize for how long it is. It is a lot of stuff to cover, but I appreciate your hard work following along. It says, write each quadratic function in standard form, which is y equals ax squared plus bx plus c. So we're going to need to do some foiling and some multiplying here to get this to look like standard form, okay? So if you recall, FOIL stood for firsts. Oops, that's a fit S. Firsts, outsides, insides, and lasts. Okay, so let's go through this together here. So we're going to multiply the first, we have x minus 4, y equals x minus 4 times x plus 7. We're going to multiply the first terms in both expressions. We're going to multiply x times x, that's the first. So they're the first on both, right? So x times x is going to be x squared. Then we're going to multiply the outsides, which is going to be x and 7 are the outsides of both of these problems here. So x times 7 is going to be plus 7x. Then we're going to multiply the insides of both these expressions, which is -4 times x, so the insides, which is minus 4x. And then we're going to multiply -4 times 7, which is going to be -28. So it's just kind of a procedural thing, but as long as you multiply x times everything in the other parentheses and -4 times everything in the other parentheses, you're going to be fine. This is kind of a shortcut, and people seem to like it. So just multiply x by everything, and then -4 by everything. But it is first, outsides, insides, and last when you're multiplying two binomials like this, okay? So our answer is going to be, are there any like terms here for this problem? X squared plus 7x minus 4x minus 28. We got 7x and -4x are like terms. So 7x minus 4x is going to be positive 3x minus 28. And that is our final answer. We converted it to standard form by foiling or multiplying, distributing everything twice. All right, last example. This is a very, very long lesson. Thanks again for sticking around. All right, so this first one here, we have y equals 2 times the quantity of x minus 3 all squared plus 17. Well, first thing we need to do is this x minus 3 squared means we're multiplying x minus 3 times itself twice, right? There's two x minus 3s. So we need to go ahead and FOIL this. We're going to do x times x we're multiplying here. So x times x is going to be x squared. Then we have x times negative 3 outsides, which is negative 3x. Then we have insides, which is negative 3 times x, which is negative 3x. And then, we have negative 3 times negative 3, which is positive 9, which is the last. Combine like terms. Negative 3x minus 3x is going to be x squared minus 6x plus 9. If you knew the shortcut for multiplying perfect square trinomials like that, you can go ahead and do that shortcut. That works. But now we're going to take that, we're going to plug it into the original equation. So we're going to do y equals, we're going to do 2. We're going to replace it with x squared minus 6x plus 9, all plus 17, because that's what this is equal to. This equals this. All right, now we're going back to distribution. We need to multiply 2 by everything in the parentheses. 2 times this, 2 times that, and 2 times that. So y equals 2 times x squared is 2x squared. 2 times negative 6x is negative 12x. 2 times 9 is 18 plus 17. Any like terms? Yep, we got 18 and 17. So our final answer is going to be y equals 2x squared minus 12x plus 35. And that's going to be our final answer with no other like terms. I went through that kind of quickly because that is a review from Algebra 1, and I want to make sure this video didn't get too long. But if FOIL is confusing for you, just multiply, like I said, x by everything in the other parentheses and negative 4 by everything in the other parentheses. And then just combine like terms and you're good to go, okay? Same thing over here. We had to multiply 2 by this, by that, and by that until we got everything all multiplied by 2. All right, thank you so much for watching. Feel free to bring some questions to class. Have a great day, and we will talk soon.